Hello and welcome to my YouTube channel. Here we are with another question answer session. In this session, we're going to talk about the coupling constant, the crystallite size determination, and a reaction sequence that is to be solved. So stay tuned, let's begin. Right, so the first question has been asked by Zahid, and it's a continuation of his previous question about the factors that affect the coupling constant. And he has asked about the coupling constant between hydrogen and fluorine and its comparison with platinum hydrogen. So, Zahid, as I've told you earlier, there are certain factors that affect the coupling constant values, and a combined effect of all these factors then determines the overall value of the coupling constant. We can have a different session, a complete session on this, and try to explain it further in that session. So I think we'll keep it for later. The second question has been asked by Shima, and it's about the determination of the crystallite size with the help of XRT. So the XRD peaks or the XRD pattern helps us to determine the crystallite size using Scherer equation that you can see on your screen, in which there are certain values like K is the constant, and inserting the values, each value in this equation will give you the crystallite size. So yes, Scherer equation will be used for determination of the crystallite size. We can have a complete session on the screen later on at some stage and see for real how we can determine the crystallite size from a real XRD pattern. But for that, we'll have a separate session. Right, the third question has been asked by Asif, and he has sent a reaction sequence that he wants us to solve. So I'll take you to the screen and show you the equation that you can see here, and see how it can be solved. So let's go to the screen. Right, so let's see what our equation is. So we have ethyl acetoacetate, and it has been treated with sodium ethoxide in the first step, and in the second it has been treated with benzyl chloride. Then in the preceding step it is treated with aqueous basic solution and heated, and finally it is treated with an acid. So what's the product? This is the question asked by Asif. So let's see what our reactants and reagents are. So we have ethyl acetoacetate. A very interesting and important feature of this molecule is the presence of this CH2 group. This CH2 group is known as an active methylene group, and it is active because of these two carbonyl groups on both sides of this CH2, which makes these two hydrogens highly acidic. And guess what? We have a base in the form of sodium ethoxide. So this sodium ethoxide abstracts one of the protons from this active methylene, which forms a carbanion, which is resonance stabilized with this carbonyl here. So it forms an enolate in the first step upon treatment with this base. Now in the second step it is reacted with this benzyl chloride. So what this enolate does is that it collapses back, and through this carbon of the enolate This CH2 group of benzyl chloride is attacked because this carbon is electron deficient due to the negative inductive effect of this chlorine. So it attacks here, getting rid of the chloride ion, forming this molecule. The ketone is restored, and we have the ester here, and now we have this benzyl group attached at this position. So this is what we get after this first sequence of 2 steps. Now in the next step, this molecule is treated with a base, potassium hydroxide. So this hydroxyline, what it does is that it hydrolyzes this ester and converts it into a carboxylic acid. And under the same conditions, because we have base here, so this is deprotonated, and ultimately it gets rid of a molecule of carbon dioxide, and a carbanion is generated as a result, which is then quenched by this acid in the last step, and as a result we get this phenyl group attached to 2 CH2 groups, and then a carbonyl, that is a ketone, and a methyl group at the end. So this ethyl acetoacetate is converted into this ketone with the help of, or in the presence of, benzyl chloride. So this was the solution to your question. I hope you have got your answer. So this is it for today's session. I hope you have got your answers, and I hope you have enjoyed it. For rest of the viewers, do send your questions on the email address given below. I'll be waiting for your questions. See you next Friday with new questions and new knowledge. Stay tuned. See you later. Thank you so much.